right, hi students. I couldn't find a short, great video, so I'm just going to make my own. So we're going to talk about weighted networks. So a weighted network is basically a network. Let's say I have a bunch of nodes, and if I want to see the path, we have some points or lengths that are assigned to each of them, each of the paths. So then if I was moving along them, I would figure out like how long it would take me, or the cost, if these were like prices, how long it would take me to make that path, okay? So there's two different words, and I might use these interchangeably on accident, but a walk and a path. So a walk is a directed order through a network. So like if we look down here, a walk, if I went from 1 to 2 to 5 to 2 to 3 to 4, that's going through here. So 1 to 2 to 5 to 2 to 3 to 4. I don't have to go all the way around, but it tells you the order that we're doing. And so if it's not labeled, then these are all just one long. So it's saying like, oh, that was 1, 2, 3, 4, 5. That's why it says it's a walk of length 5. So you have to go in that path, okay? You don't have to use all the nodes. You don't have to use all the edges. You can end up where you want. You can start where you want. A path, very specifically, it's a walk where all the nodes and all the edges are different, okay? You don't have to use them all, but remember how we went from 2 to 5 and then we went back to 2? That repeated those. So a path is if I went 1 to 2 to 3 to 4 to 6. They were all different. Okay? So if you see these words and you're like, I don't really understand the difference, it's a very slight difference, so it's not a big deal. Okay? All right, so now what we're going to do is we're going to assign some values to each of the edges. All right? So for number 1, it says find the total value for PRCATK. All right, so I'm going to use colors to kind of add them all up. So we're going to do P to R. So that's 27. And then, so that's P to R. And then I need to go to C. So that's 16. Then I need to go to A. So that's 24. And so on your work, I would just see these numbers. Then I would go to T. And then I would end at K. That's 10. Okay, so then we just want to add all these up. So 27 plus 16 plus 24 plus 18 plus 10. 95. And that's it. That's the total value. So if these were prices or minutes or lengths or miles, it doesn't matter, but you can kind of see the application. Like you use this every day. You just don't think about it. Like when you're driving somewhere or whatever. All right, number 2. Give 2 different weighted values for walks from C to P. So remember, a walk means I can repeat them. It doesn't matter. Okay. I can start anywhere and I can stop anywhere. So we want to go from, let's erase. All right, so I want to start at C and I want to go to P. Okay, so one might be C to R to P. So C to R to P. So C to R is 16. And then R to P is 27. And so if we add those together, we get 43. That's one weighted value. Now let's do green. I also want to start at C and I want to end at P, but I can go a different direction. So let's just say I went boom, and I'm just totally making this up. Boom, boom, boom. Okay, so I want to do C, A, T, K, P. So 24 plus 18. Then we went 10, and then we went 14. So if I don't specify, it just means I started and I ended there, but I really could have taken any paths that I wanted to. They could repeat, they don't have to. There's lots of different answers. So this one's 66. Okay. So that's why naming your letters in order, that tells me how you're traveling. All right. So it's pretty simple. So this one, we're going to be given a picture with weights and nodes. So it says we have a snowplow operator. This is really good for, this is kind of how they plan, honestly, the best route through a city. Because, you only have so much time, you have so many streets, garbage collectors do this, mailmen, like lots of different jobs use this information, okay? You just never really think about it. You're like, oh, they just go from house to house. It's like, well, they need to figure out their route though, because sometimes you're like, why is the garbage man going that way? Well, they figured things out, okay? So we need to plow all of the roads and we need to return to our starting place, okay? So the time estimates are given. So state number 1 and give us total time values. So let's just say, I don't know. We'll start at B. I'm just picking one. So, and I need to plow all of them. So let's do B to A to C. And I'm doing my colors to make sure I get all my streets. We'll go up. And then let's do D. I have to do another route anyway. Let's do E. Let's go back. 7. Let's go here. Let's go here. Here. And then I got to end up back at B. Oops. I wrote 3 instead of D, sorry. And then B. Let's do D. Okay. So, all right, I'm just going to use my calculator. So B to A. So we've got 3 plus, we went to C, 6 plus, back to B, 7 plus, I went to, so what was that, 3? I'm just writing it. You don't have to write this for me. So 3 to 6 to 7. So then I'm going to go to D, so 2. And then E, 6. Then I'm going to go to B, which is 3. And then to C, so 7. To E, 3. To F is 4. Plus F to D is 3. And then back to B, so 2. So I got 46. Okay. And then I just say state a possible second route. So I'm going to get rid of this because I need to see my colors so I know that I've hit everywhere. Sure, let's do blue. So let's start somewhere else. What if we start at A? I'm going to write my numbers down as I go. So I really can go anywhere, I guess. I'm going to have to hit both of these. So let's do A to B. And then let's see if we can go on the outside. Let's do D. Let's do F. I'm really just playing here. There's no right or wrong way. We're going to go to E. See, I have like 3 paths here. So what if I did, let's go to B. I need to come back and get this. So 2 is not very long, so I'll do that. I can drive 2 minutes. Then I'll go to E. Then I'm going to do C. And I've got to end up there. I guess I'll go, oh, but I have to get 6 and the 7. Ooh. I'm going to have to backtrack, I guess. Ooh, this was not the best route. B is 7. Then I guess I'll go back. And then I'll hit A. So let's go ahead and add those up. That was a lot easier, I think. 3 plus writing them down as I went. Ooh, I have 46 minutes again. Now, it can be a coincidence. Some of your paths, depending on your go, they will be the same amount. Some will be different. So don't worry about that. Okay. Obviously, the whole idea is depending on your route, you might get different values, but you realize like, ooh, maybe I didn't want to backtrack the 7. Backtracking a 3 was probably better, or backtracking a 2. So that's kind of the idea. All right, so when would weighted networks be used in real life? Well, honestly, this is how I use my Google Maps to go everywhere. So this is what's programmed in them. They're calculating all the distances between the locations and intersections, and they give you different options too, and they tell you exactly how long it takes. That's using Dijkstra's algorithm. So Dijkstra was a mathematician, and he found the shortest distance between the destination. Now, sometimes I don't always pick the shortest. It really depends on, like, I look at the map and I see which way do I really want to go. But if you want to learn more about Dijkstra and his rule, how he optimized this, you can watch this video, okay? I won't be testing you on that, but I thought it was like, oh, wow, we actually do use Dijkstra's algorithm all the time. Or at least I do, because that's how I travel. So on your assignment, I'm going to have you give some weighted path values, give some path letters, and that's really about the practice.